Today, I'll be talking about electromechanical systems. Okay, what are electromechanical systems? Okay, electromechanical systems. In electromechanical systems, we study the interaction and the relationship of the mechanical elements with electricity. Okay, there can be various electromechanical systems like we have transformers, we have generators, we have got motors. Okay, and such systems are known as electromechanical systems. Okay, so in order to understand the applications of the electromechanical systems, okay, we were assigned a project, okay, an EMS project, okay, and the project I've opted is about, is to develop a DC motor, okay. And before understanding my project, we must know what is a motor, okay, what are the related components, okay, before understanding the project. Okay. Now, let's come towards DC motors. Okay, before doing that, we must know the definition or the basic of that, which is motor. Okay, motor is such an electrical device that converts electrical energy into mechanical energy. Okay, how can we elaborate it? If I elaborate it, then for example, I want to uplift water from the ground level to an upper level of a house, then I'm supposed to use a motor. Okay, in that motor we'll be using electricity. We'll be giving electricity as an input power, and it will be giving us some output power, and it will provide it the mechanical energy to uplift that water. So we can conclude here that motors are used to provide some mechanical power. Okay, they are used to provide some mechanical power by taking in some electrical power. Okay, there are two types of motors. There is DC motor and AC motor. The only difference between DC motor and AC motor is that in DC motor we have direct current source, okay, while in AC motor we have alternating current source, okay, and rest of the definition is same. Now, though generator is not the part of my project, but I'll be explaining it, or I'll be giving a gist of it, so that I can make you understand more about the electromechanical systems. Okay, so what are generators? Generators are such devices, such electrical devices that convert mechanical energy into electrical energy. Okay, how can I justify it? Okay, in generators we have some fuel. Okay, some fuel, it can be diesel, it can be petrol. Okay, they have some bonds in it. Okay, if there are some bonds in it, then when those bonds burn, okay, they will be producing some energy. Okay, and that energy would be used to produce some electrical energy. Okay, hence we can say that we give it some mechanical input. Okay, some mechanical input in the form of bonds. Okay, and due to that, okay, it would be producing some electrical energy. Okay, it would be providing us some electrical power, okay, as a result of that mechanical energy. Now we'll be talking more about DC motors. Okay, what are DC motors? As I've already told you, that DC motors are such motors in which we convert electrical energy to mechanical energy, but the input source is DC current. Okay, that is the definition of DC motor. Okay, so we must know that in DC motors, what are the components? Okay, the components can be an armature. Okay, that armature is the rotating part of that magnet. Okay, and we have that motor, sorry, and we have some magnet as well. We have an electric source as well. Okay, and due to we provide that motor, okay, some power, some electrical power. Okay, and that electrical power would be used to rotate that armature or that coil. Okay, as we know that when a current carrying conductor is placed in a field, okay, in a magnetic field, then that conductor experiences a force. Okay, and due to that force, okay, it will have a rotation. Okay, and this law is known as Lorentz law. Okay, which says that, or which states that when a current carrying conductor is placed in a magnetic field, then a force will be applied on that conductor, and that force is known as the Lorentz force, and the magnitude of Lorentz force is equals to F is equals to ILB sine theta. Okay, so after Lorentz force, there will be some torque produced in that coil. Okay, and due to that, there will be the rotation. As we know that torque is the rotational analog of force, so due to that, it will have a rotation, and due to that rotation, it will produce some mechanical energy. Okay, and it will be converting into electrical energy, will be converted into mechanical energy. Okay, after that, we must know that Due to the rotation of that coil, okay, we know that when a coil rotates in the magnetic field, then there is a change in flux. There is a change in magnetic flux. Due to that, okay, an EMF will be induced in that coil, okay, and this is in accordance with the Faraday's law of electromagnetic induction, okay, and due to this, it will have an induced EMF, and that EMF is known as back EMF, okay. This is known as back EMF because it opposes the voltage source, okay, voltage current source, okay. And here there is the application of Lenz's law, which states that the effect will always oppose the cause. And here the question arises that why I've opted DC motors and why I haven't opted AC motors, because DC motors are, they are used, widely, because we know that AC motors are, though, smaller in size, they are, they are smaller in size, less expensive and more reliable, okay, we know that. But the defect or the drawback of AC motor is that it has a fixed speed, okay, and that fixed speed is determined by its line frequency, okay. On the other hand, DC motors have a non-uniform speed, okay. We can change the speed, we can even change the direction of rotation of that DC motor, and we can also change its torque, okay. So, and the thing we can conclude is that DC motors are more general and they're wider, okay, while AC motors are restricted, okay. And we must know that in DC motors it provides us greater starting torque because the winding and the armature are in series, okay. If they are in series, the current will flow more, and due to that current, the torque will be greater. Now let's move towards, let's be more specific and let's move towards our project. And the components for my project are, the wire, okay, the magnet wire, okay, the magnet wire, the magnet, I'll be using some electric current source. Along with that, I'll be using a conductor, okay, and I'll be using a wooden block, okay, I'll be using screws, okay. So first of all, okay, when I'll be providing some electric current to that to the conductor, okay, which is placed inside the magnetic field, then it is obvious that it will experience a force, okay, and due to that force, okay, it will have a torque and it will rotate, okay, it will be rotating. Due to that, there will be a rotation in that coil, and we can say that due to the input, which is electric input, okay, electric current source, okay, we'll have a mechanical effect of that. Means due to that electric current, okay, due to that electric current, we'll have a mechanical effect of that, okay. It will rotate. It means that it will be rotating, and it means we have converted the electrical energy into mechanical energy, okay. So first of all, I'll be taking the wire, okay, the magnet wire, okay, and that I have to make it round, okay, I have to make it round, and I have to remove the upper top insulation of that coil, okay. After removing that, what I have to do is that I have to fix this wire, which will be acting as the armature, okay, on a magnet. And after doing that, I have to provide it an electric energy source, okay, I have to provide it some electricity, okay. After providing some electricity, obviously there we will be using some conductor, okay. The conductor can be we can use a safety pin as well, okay, we can use a pair of safety pin as well, okay. Along with that, what will happen is that due to that electric current, okay, there will be the rotation, the production of the rotation, okay, in that coil. So we can say that this will be acting like a motor, because it is the basic functionality of motor, that it converts the electrical energy, hence it produces some mechanical power, okay. And this rotation is the indication of the mechanical power that has produced due to that conversion of electrical energy into mechanical energy. Now I'll be telling you what are the applications of my project, or the DC motor I have developed. Okay, I'll be developing rather. So first of all, we can use my DC motor where we need some mechanical power. Okay, I can use this motor in form of form utensils. I'll be using it in toys, okay, because toys do some work, some mechanical work, okay. The toys have to run, they have to tilt, and they have to walk, okay. For that they need some kind of energy, okay, some kind of mechanical energy, and that mechanical energy will be provided with the help of my motor that I'll be fitting in that, okay. So obviously, okay, I'll be providing it some electricity, okay. I'll be providing it some electricity, and it will have the setup so that it will have a motor, okay, and that motor will provide it some energy, and that energy will be required, okay, or will be used for the consumption of the mechanical power, okay, that it needs to rotate, it needs to run, it needs to walk, okay. Likewise, we also know that we can use our DC motors or what motors, okay, everywhere, okay. We use motors in computers, okay. Even computers have got motors, okay. So we can use our motors in many wide applications, okay, where we need some mechanical power. There we'll be obviously using some motors, okay. Whether it's, you know, a smaller project or it's a bigger project, everywhere we'll be using motors because they provide some mechanical power, okay, which is used to do some work. Thank you. It was all about my presentation.